All right, so today we're going to start looking at gas stoichiometry. Really, it works just like regular stoichiometry. So for the most part, if we're given a volume of gas or asking for a volume of gas, we don't necessarily need the periodic table. All right, so stoichiometry up on the board, that's what we've seen. That's what we've been working with. We know that one pretty well. I'm not going to add those shortcuts in right now. But we are going to tack on a couple things to it. So let's say rather than starting with mass, let's say that we were working only with gases. Let's say that they gave us a volume of gas. Luckily for us, chemists back in the day have already figured out that if you have, let's go volume of X of our starting material, they figured out that if we have 1 mole of a substance, of a gas, it has a volume of 22.4 liters. Doesn't matter what the gas is, you have 1 mole of it, you have 22.4 liters of it, which is quite a bit. So using that conversion, to go from volume of X to moles of X, our first conversion is just 1 mole of X over 22.4 liters of it. That's kind of just like if you're starting with mass of X and wanted to go to moles. We took it times 1 mole of X over the molar mass of it. Except this time we're using volume, not molar mass, right? So that gives us some moles of X. To go from moles of X to moles of Y, it's the exact same thing. It's just the moles of Y over moles of X taken from the chemical equation. But now let's say that we need to find the volume of something else, the volume of Y. So just like the way that the mass ones work on your shortcut, it's just the reciprocal of what those conversions are. So in this case, it's just moles of Y times 22.4 liters of whatever our Y is over 1 mole of it. All right, so let's see what that kind of looks like in practice. So let me scroll down a little bit. All right, so that should be added to your shortcut. It's also on the backboard. It's going to be up for about a day or two, and then it's going to be gone. All right, so let's see how that actually plays out. So scroll down, go back to this equation here. All right, so 2 of these are gases. The H2 and the O2 are gases. And if I wanted to rewrite this a little bit, I could write it as this. The parentheses G just tells me that it's a gas. So I'm able to apply those gas conversions to it. Cursive letter L just tells me it's a liquid. I can't find, using stoichiometry, the volume of a liquid. It's just that there's no universal rule for that. It's based on density. So that just tells me I can't use the 22.4 thing for the water. But I can use the gas thing for the H2 and the O2. So let's say that I have 9 liters of H2. And I want to know what volume of oxygen gas do I need to react all 9 liters of H2. All right. So that's my X. That's my Y. So starting off with, write down what we have, which is 9 liters. First conversion from your shortcut is we need to go from the volume of X, because I'm given liters, I know it's volume, to the moles of X. So that first conversion is 1 mole. My X is not X. My X is H2. And that one, no periodic table needed. That shortcut tells me that's over 22.4 liters of H2. Next conversion is moles of Y over moles of X. So what I'm looking for is the volume of O2, so that's my Y. Up here, there's nothing there, so there's 1 mole of O2 for every 2 moles of H2 needed. All right, one more conversion. So now I'm down to moles of Y, and I need to get to the volume of Y. When you check your shortcut list, that just tells you it's 22.4 liters over 1 mole of Y, or O2. Unit analysis shows me liters of H2, liters H2, moles H2, moles H2, moles O2. Moles O2, I know I went through that quickly. Big thing though, liters of O2 is what I'm left with, which is what I want. Dig out my calculator quick. So I have 9 divided by what's on the bottom. So divided by 22.4. Divided by 2. Times by whatever's on top. So times 22.4. All right. So in this case, I get 4.5. And that's liters of O2. And that makes sense. If I have 9 liters of H2, and according to the formula, for every 2 moles of H2, I have 1 mole of O2. It makes sense that the volume of O2 we need is half the volume of the H2. So this is based on volume, not molar mass, which would be different. All right. So going through one more aspect of this. Same equation. All right, this time though, we're going to start with, we'll start with 15 liters of O2. That's my X. And I want to know what mass of water will be produced. All right, so this time we're not going volume to volume. We're going to go volume to mass. So starting off with, write down what we have. So 15 liters O2. Have to recalibrate. All right, first conversion, a little bit bigger. 22. No, I messed up already. It's 1 mole of O2 over 22.4 liters of O2. Second conversion, moles of Y, or moles of what we're looking for, so that's H2O. Up here, that's 2. Over 1 mole. Because I'm working with O2, chemical equation gives me 1 mole. All right, last conversion, I'm asking for mass. So this time I'm not going from moles of Y to volume of Y. I'm able to follow the arrow to go from moles of Y to mass of Y. I have 1 mole H2O on the bottom. Molar mass of water of H2O, oxygen 16 plus 2 hydrogens is 18. So I have 15 divided by what's on the bottom, so divided by 22.4, multiply by what's on top, times 2 times 18, and I got 24.1 grams. All right, gas stoichiometry, all that it did is it gave us a new starting point and a new ending point to choose from. Going back up here, I can start from volume of something and end at moles of something. It's all about figuring out which of the 3 points are you starting at, which of the 3 points are you ending at, and then just following the arrows to get there. We've been doing mass to mass, mass to moles to moles to mass. But now we can go volume to moles to moles to volume. We can go volume to moles to moles to mass. We could go mass to moles to moles to volume. We could go volume to moles to moles. We could go moles to moles to mass. You know, it's all about just where are we starting? Where are we ending? How you know where you're starting? Mass is given to you in grams. Moles are given to you in moles. Volume is given to you in liters. All right, so hopefully that helps out. The problems will be online, so good luck.